drop a message or unmute yourself and tell me that how to complete this numerical. So we can proceed for the solution of it. So what are the points of it? We can discuss once you said me that I have to write this numerical in notebook. Have you finished, students?
Yes, sir.
Okay. Thank you for confirmation. So I'm sharing the next screen with you. So you see that there is a heat pump. You see in numerical in which the problem statement is given that a heat pump is used to maintain the house at 25 degrees Celsius. So the hot reservoir, that is T1, you say that TH, the temperature is given in the numerical at 25. So given data, please write down in your notebook. T1 is equal to 25 degrees Celsius is equal to 25 plus 273 is equal to 298 Kelvin. So the temperature of this hot reservoir is around 298 Kelvin. Secondly, after finishing this one, the second line is that the house is losing the heat at a rate of 60,000 kilojoules per hour. So as you see the figure, the hot reservoir, so one arrow comes out from this red hot reservoir and show it's losing the heat from the hot reservoir to the surrounding with the rate of 60,000 kilojoule per hour. Then after this one to the surrounding, while the heat is generated in the house by the various appliances. His word is the various appliances. So it's not the value of Q1, right? So while the heat is generated in the house by various appliances 40,000 kilojoule per hour. So as you see on the figure, hot reservoir. So add one more arrow indicating that 40,000 added in the hot reservoir. Don't show the value of QH, right? Or you can say Q1. ये वैल्यू 40,000 Q1 का नहीं है और 60,000 में वो भी QH नहीं है और Q1 नहीं है. तो आपको दो अलग अलग एरो दिखाने हैं. एक एरो आपको साइड से दिखाना है, साइड से मींस यहां से ऐसे. It is comes inside 4,000. It loses surrounding with the 60,000 kilojoule per hour. See my cursor direction, right? Then your next statement is, it is in kilojoule per hour. If the COP of the heat pump is 1.5, so write down in a given also this quantity. Once you write down this heat is losing, house is losing the heat at the rate of 60,000, it's a given. Then also write heat is generated in house is 44,000 kilojoule per hour, it's also given. And COP of heat pump, you write down COP of heat pump as we written in this equation. in previous slides. So accordingly, I can write down the 4000 kilojoule per hour COP. And you have to find out the power required to drive the pump in watts. So P is we have to calculate it. P, or you can say W. Both are the same. So might you have write down some formulas in previous lecture. So according to the given data, first thing I have to clarify that we have to provide with the temperature T1 in this equation, in this problem statement. And the value of T1 is equal to 25 degrees Celsius is equal to 25 plus 273 is equal to 298 Kelvin. For that case, to calculate the power required to drive the heat pump. So you look at the formulas you wrote in a previous lecture, and according to the given values, that is the T1 and COP, we have to calculate a W, which equation we require. Let me know that. आप previous जो equation आपने लिखी है, सब equation को देखो और उस equation से हमें W किस equation से मिल सकता है वो मुझे बता.
COP is equal to QL divided by work net.
Okay, for QL, it's a heat pump. So it's not QL, it's a QH. You can say Q1, okay? For heat pump, desired point is QH. Kindly note, okay? So, if COP of heat pump is equal to desired effect, that is Q1 upon power input or work done is equal to W. So, you know the value of W, yes or no?
No, sir.
No,
So
sir.
you need to calculate W. Okay? You need to calculate W. Secondly, you know the value of COP?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
You know the desired effect, that is QH or Q1? You have the
Sir.
value of Q1?
No, sir.
You don't have the value of Q1. So first thing, you need to get the value of Q1. Okay. So I'm request to all the students is that the image you show on your screen, जैसे हमने लास्ट न्यूमेरिकल में एक सिंपल सा बॉक्स डायग्राम ड्रॉ किया था, वैसे बॉक्स डायग्राम ड्रॉ करो और जैसे मैंने आपको बताया वैसे सब क्वांटिटी वहां पे शो करो. उसके बाद मुझे बताओ, सो मैं आगे का स्टेप आपको बताता हूँ. ओके, क्या सभी ने ड्रॉ कर लिया डायग्राम जो आपको स्क्रीन पे दिख रहा है वैसे?
हाँ सर, ड्रॉ कर
Yes,
लिया.
sir.
सिंपल डायग्राम हमने लास्ट इक्वेशन लास्ट न्यूमेरिकल में ड्रॉ किया था ना कल, जो जैसे वैसे ड्रॉ करना है. 3D में ड्रॉ करने की जरूरत नहीं है, सिर्फ ऊपर का एक बॉक्स, then straight line, the circle, and the last box that is you see in blue color, and work is input intensity, and circle के अंदर लिखो heat pump. बस हो गया आपका डायग्राम. एंड जैसे मैंने आपको बताया, यहाँ पे एक एरो दिखाना है जिसमें आपको 4000 इनपुट आ रहा है बॉडी को, और यहाँ से एक एरो दिखाना है जहां से आपको लग रहा है कि 60000 सराउंडिंग को रिजेक्ट हो रहा है. हो गया इतना सबका?
Yes, sir.
Okay. Now for that case, to get the Q1, right? I am changing the screen to all of you. So here write in this according to this diagram. For the calculation of this Q1, heat loss from the house to the surrounding minus heat generated in the house. Write down this in your notebook. So 60,000 minus 4,000 is equal to 56,000 kilojoule per hour. So in this way, you get that the value of Q1 here. So once you get the Q1, you get that COP, Q1 and W. So from this equation, you calculate that W is equal to 10.37 kilowatt. लेट्स चेक आपका आंसर सेम आ रहा है कि नहीं. ये जो ऑथर का जो बुक है इसमें बहुत सारी मिस्टेक्स है, सबका आंसर सेम आना चाहिए. अगर नहीं आ रहा है तो लेट मी नो. एंड यू हैव टू कन्वर्ट दिस 50,000 इनटू किलोवाट by multiplying this 60 by 60 because it is hour. So you know that joule per second is watt or kilojoule per second is kilowatt. Solution in front of you. Kindly write down this solution. And let me know that the value is exactly coming 10.37 or not. You have to calculate with yourself. यहाँ पे जो आपको लग रहा है कि सिंपल मल्टीप्लिकेशंस है, so ये गलती एग्जाम में हो सकती है. So kindly do calculations yourself using calculator and check whether you get the same value or not. $10.37 correct. Okay, everybody get your answer. Thank you, Sohan.
Yes, sir.
Thank you, Yash. Remaining students, what is your opinion? You get it value 10.37 correct?
Yes, sir.
Okay, okay,
Yes, sir.
okay. So
Yes, sir.
can we proceed for the next numerical?
Yes, sir.
Yes or no? Please let me know so I can change the screen with you.
Yes, sir.
Okay. Just
Yes,
a minute.
sir.
Just a minute. I will change the screen now. We have three different concepts: heat engine, heat pump, and refrigerator. So heat engine is remaining. So we proceed for now heat engine. A heat engine operates between the source and the sink temperatures of 235 degrees Celsius and 30 degrees Celsius respectively. Means that value of T1 is 235 and the value of T2 is 30 degrees Celsius. In that case, if heat is engine receives 35 kilowatt from the source, means the value of Q1, heat is received in the source, right? 35 kilowatt. Find the net work done by the engines. Mean net work done का formula क्या है हमारा? Work done is equal to Q1 minus Q2. To get this value, we require Q1 and Q2. The heat is rejected to the sink. This means value of Q2 and the efficiency of the engine. You know that how to calculate the thermal efficiency of the heat engine. आपने ये formula लिखा हुआ है sketch of the system. So it's a request to all of you kindly write these formulas, numerical in your notebook. Once you write this numerical, let me know. And you know that the solution T1 is equal to 235 degrees Celsius. So add it is 235 plus 273 is equal to 508 Kelvin. And T2 is equal to 30 degrees Celsius is equal to 303 Kelvin. ये लिखने के बाद आप मुझे बता सकते हो कि हमें कौन सा फॉर्मूला सबसे पहले यूज करना पड़ेगा. सो हमें आगे का वैल्यू मिलते जाएगा. आपने जो फॉर्मूले लिखे है उस फॉर्मूले को देखो, आपको क्या गिवन डेटा दिया गया है वो देखो और उसके बाद मुझे बताओ कि हमें कैसे प्रोसीड करना पड़ेगा. आपको सिर्फ फॉर्मूला बताना है और उसमें वैल्यू पुटअप करने हैं और उसको सॉल्व करना है. सिंपल से कैलकुलेशंस होते हैं, जैसे T1 को आपको कन्वर्ट करना है केल्विन में, तो kindly do it. So every calculation of this unit is must be in Kelvin temperature. हो गया स्टूडेंट लिख के?
Sir, wait, sir.
ओके if you are able to draw the sketch of the system, you also draw the sketch of the system. हाँ, अगर आपको आ रहा है हीट इंजन है तो क्या दिया है आपको वहाँ पे स्केच पे दिखा सकते हो, अगर अगर आपको आ रहा है तो डायरेक्टली. Dear student, there is no request for me. Nikhil, I don't have any requests pending for adding in class or joining the class. Please ask him to rejoin the class. So, can you let me know that in which direction we can solve this numerical? By using
Sir,
the given
We
data?
have to draw the figure.
Yes, yes, you can proceed. 1 minute remains. Yes, you can proceed now.
Sir,
हम
first we have to draw the figure, no?
वर्क डन निकालना पड़ेगा बट उसके
यश
लिए
यश केशरवाणी 1 मिनिट थांब बाळा, तो दुसरा यश बोलतोय बी डिव्हिजनचा 217 नंबर. थांब. हा
तो पहिले
217
figure काढावं
217
लागेल
यू
ना.
प्रोसीड नाउ. यस.
हाँ
सर पहिले
सर
फिगर काढावं लागेल ना.
क्यू आउट निकालना पड़ेगा बट क्यू आउट कैसे निकालना है ये पता नहीं.
आपने जो इक्वेशंस लिखी है प्रीवियस लेक्चर्स में उसको जब देखो उसमें हमें क्या मिल सकता है वो बताओ मुझे. अगर आपके पास T1 है, T2 है और Q1 है तो हमें कहाँ लॉजिक यूज करना पड़ेगा कौन से इक्वेशन का. सो हमें जो वैल्यू है Q2 का भी मिल जाएगा, नेटवर्क डन भी मिल जाएगा और इफिशियंसी भी मिल जाएगा. I think so. You have to write down one of the equation in last to last lecture. That is the thermal efficiency of the heat engine. किसने लिखा है क्या?
यस सर.
क्या है thermal efficiency का equation?
नीट वर्क डन अपॉन क्यू इन हीटिंग.
So in terms of temperature, I have to write down this equation.
सर टेम्परेचर नहीं पता सर.
Just a minute. मैंने आपको पहले ही बोला था कि आप ये सब है ना लिख के रखो क्योंकि आपको लगने वाला है ये. Wait for a minute.
Hello, sir.
Yes, it is not here. This is in terms of temperature. So
Hello, sir.
Yes.
इसका फॉर्मूला Q1 अपॉन Q2 इज इक्वल टू T1 अपॉन T2 ऐसा आएगा क्या?
Okay, so how can from this value formula, what do you get?
सर 1 माइनस T1 अपॉन T2 आएगा क्या सर?
Yes, 1 minus T1 upon T2. That is, you will get the thermal efficiency for it, right? So once you get the thermal efficiency, yes, you can proceed now. So let I know to you. There's 1 minus T1 upon T2. So you get a thermal efficiency, right? So once you get the efficiency, then how can proceed to calculate Q1 and heat rejected Q2?
T1 upon
Yes.
T2 Q out upon Q in.
Yes.
T1 upon T2 इक्वल टू Q out upon Q in. इस तरीके से
Okay.
हम लिख सकते हैं.
Okay. Then what about this here Q2?
Yes sir, एक मिनट सर. हाँ.
Yes, 217 नंबर बाळा तू सांग आता.
Sir, for heat engine, the efficiency is smaller than 1 or greater than 1?
Greater than 1.
Okay, thank you.
So anybody knows about that? How to get this value of net work done? For net work done, we know that Q1 minus Q2 or other formula if you know that COP, but heat engine there is no COP. So you must know that the value of Q1 and Q2. So how to get this value of Q1 and Q2 and next is the net work done. So from these equations of T1 and T2, that is 1 minus T1 by T2, you get an efficiency, right? Let's check the solution. Don't worry about that. See now, from this efficiency that efficiency is equal to 1 minus T2 by T1, not T1 by T2. So you get that is 1 minus means is opposite to that one. Q1 upon Q2 अगर है आपका जो efficiency equation in terms of T2 change हो जाता है, it's a T2 by T1. So it's about 303 by 508. So you get is about 40.35%. You draw this sketch in your notebook. Accordingly, this is your say T1 235 is equal to 508 Kelvin. Q1 is equal to 35 kilowatt. It's the heat engine E or HE work done by the system. Rejects heat to the low temperature sink. T2 is equal to 30 degrees Celsius is equal to 303 Kelvin. So first you need to find out the net work done, that is Q1 minus Q2. You must have the efficiency is equal to 1 minus T2 by T1 is equal to you get at 40.35354. Once you know that efficiency equations, use the efficiency equation again. So you know that efficiency is equal to output upon input. So work output here you need to calculate. Efficiency you know that and heat input you know that. So from this multiplication of efficiency into Q1, that is 0.40354 multiplied by 35, it's in kilowatt. So you get net work done is equal to 14.124 kilowatt. Let's know that it is values correct or not. Once you know that this work done, so from equation that is first law, W is equal to Q1 minus Q2. So to calculate Q2, it's the Q1 minus W. So 35 minus 14.124, you get at 20.876. And from the equation, this T2 by T1, 1 minus T2 by T1, you get it at the efficiency of the engine is equal to 40.354%. Let me know that this value are correct or not. Calculate it and let me know.
तो थोड़ा स्क्रीन नीचे कीजिए तो.
बस
सॉरी सर, ऊपर कीजिए, ऊपर. सॉरी.
Let me know that every value is correct or not after calculation.
सर
Yes.
फर्स्ट पार्ट दाखवा ना, खाली घ्या ना थोडंसं.
काय म्हणते बाळा?
खाली घ्या ना, फर्स्ट पार्ट नाही दिसत आहे.
स्क्रीन दिसत नाही का तुम्हाला?
स्क्रीन दिसते सर, फर्स्ट पार्ट नाही दिसत आहे आन्सरचा.
फर्स्ट पार्ट.
सर आंसर करेक्ट है सर.
Remaining students get calculated it and let me know.
Correct sir, answer is correct.
करेक्ट है सर.
Okay, okay.
Correct है
So
sir.
जो आपको यहाँ पे सॉल्यूशन दिख रहा है ना, सभी ने सॉल्यूशन ऐसे ही लिखना है. So if they are asking to draw the sketch of the system, if the sketch is given, so it's very well in the problem statement. So if not given, so 2 marks carried by the sketch in the examination. 2 मार्क आपको सिर्फ स्केच को होते हैं, ध्यान में रखो. अगर आपने वहां पे स्केच ड्रॉ करके भी आए और आपका सॉल्यूशन गलत आता है और वैल्यू गलत आती है, तो जितना स्टेप सही है उतने मार्क्स आपको मिल सकते हैं. सो काइंडली नोट दैट बाय यूजिंग जस्ट इनिशियल्स यू नो दैट कि आपको क्या सिस्टम ड्रॉ करना है. So completed.
Yes sir.
Remaining students.
Yes sir.
Yes sir.
Okay, so I'm changing screen now. Just a minute. So I will provide you right now one problem statement. You write it on a notebook, right? Simple problem statement, and let me know the solution of it. It's regards with the refrigerator. Simple problem आपको बताने जा रहा हूँ. So dictate करो इसे. Can I start? Can I start, students? Yes. Yes or
Yes,
no?
sir.
Okay.
Okay.
So write in your problem statement. It's regards with the refrigerator. A refrigerator with COP of 1.5.
Yes sir.
A refrigerator with COP of 1.5 absorbs heat from food compartment.
सर रिपीट करो ना.
Okay, just a minute. And captions on English. Are you able to see my screen now?
Yes sir.
Yes sir.
Okay. So what happens, you see that whatever I am telling to you, it will be show on your screen, okay?
Yes sir.
A refrigerator with COP of 1.5 absorbs heat from food compartment. At the rate of 360 kilojoule per minute. Draw the sketch of the system. Find out one, power consumed by refrigerator. Two, the amount of heat rejected to surrounding. Have you written it in your notebook?
Yes, sir.
Yes, sir.
So kindly solve
Yes,
and
sir.
let me know the answer of it. So what is given data in problem statement? Can you know that?
Q in दिया हुआ
QP
है.
is given 1.5, right?
Yes, sir.
And the second thing is
Q2.
that heat from the food compartment absorbs, heat absorption दिया गया है, right? So in this case, you have to provide with the value, equipment is refrigerator. So for that, heat absorbed from the food compartment. Food compartment, it's maintained at a very low temperature. Means it's the value of Q2, right?
Yes, sir.
Okay. So it is given to you that COP is equal to 1.5 and Q2 is equal to 360 kilojoule per minute. So from that two values, you need to find out the power consumed by the refrigerator and the heat amount, the amount of heat rejected to the surrounding. That is value of Q1.
So the power is 4 watt.
The power is
Kilojoule.
4 kilojoule per second or 4 kilowatt. Correct.
4.
The value of then heat amount of heat rejected to surrounding Q1. Vedant said it's 10 kilowatt.
Sir, 10 kilo.
Right, 10 kilowatt. Remaining students, can you get this answer?
Yes, sir.
Okay.
Yes,
so,
sir.
right. So first thing is that the only change you have to do here is that you need to change the value of Q2, that is 360 kilojoule per minute to 360 by 60. So it is 6 kilojoule per second. And by using the formula of the COP, you need to calculate the power input, that is W. So 6 by 1.5, you get that W is equal to 4 kilojoule per second. And by the first law of the thermodynamics, W is equal to Q1 minus Q2. And to get the Q1, you add W plus Q2, right? So 6 plus 4, you get at 10. So value of the heat amount of rejected to surrounding is equal to 6 plus 4 is equal to 10 kilowatt. You get at a simple numerical for only 5 marks. You need to write down draw the sketch also. सिर्फ वैल्यू कैलकुलेट करने से नहीं होगा, आपको स्केच भी यहाँ पे ड्रॉ करना है रेफ्रिजरेटर का अकॉर्डिंग टू द प्रोवाइडेड वैल्यू टू यू.
Okay, sir.
Right. So right now I am sharing the second screen with you. Just wait for a minute. So is the second part of unit number 2 is called as heat transfer. So I think so you know that the way of heat transfer, you learn it. What are the different media? What are the different I think 3 conditions are there for the from which the heat is to be conducted. Can you know that there are 3 different criteria?
Yes, sir. Radiation, conduction, and radiation, conduction, or
convection.
Convection, conduction, convection, and radiations. So you know that you have to study that laws of Stephen's law, Newton's law, cooling and radiation law. ऐसे आपका 12th में हुआ है क्या?
Yes, sir.
हुआ है sir.
Yes, yes. So that unit deals with that such a things, right? Simple. Just a minute. सबको स्क्रीन दिख रहा है?
Yes,
Yes
sir.
sir.
Okay.
Yes, sir.
So I have started at introduction. So what is heat transfer? So I know that you know that. So instead of this introduction part, we move to the next part. So there is why should we study the heat transfer? So in the importance of heat transfer, you know that the mechanical engine, the heat produced in the engine of the cylinder, that is RSC, refrigeration and air conditioning system, and use of the insulations, cooling and heating of the bodies, etc. So I know that one of the thing is that in the case of the engine, आपको सबको बाइक का इंजन पता होगा, सही है?
Yes, sir.
Yes
हीरो
sir.
हीरो है, होंडा है, टीवीएस है, जो भी आपने बाइक देखा होगा, उसका एक इंजन ब्लॉक होता है और इंजन ब्लॉक पे ऐसे प्लेट लाइक स्ट्रक्चर होते हैं. देखा है किसी ने?
हाँ सर.
हाँ सर.
उस पे ऐसे छोटे छोटे प्लेट्स होते हैं जिसके अंदर आप छोटा छोटा 5 mm 4 mm का गैप होता है उस प्लेट्स के अंदर, राइट? तो
Yes.
तो इंजन के सिलेंडर पे क्यों होते हैं, किसी को पता है क्या?
हीट बाहर निकाल नहीं ऐसा कुछ.
नहीं पता sir.
So it's simple thing. It's just like that. If the cylinder is round in shape, right? So whatever the heat is generated inside it, so by means of conduction, it is moved from one point to the another. Means अगर सिलेंडर के अंदर हीट जनरेट हो रहा है, तो वो जो अंदर का वॉल सरफेस होगा और बाहर का वॉल सरफेस, उसका कुछ थिकनेस होता है, राइट? So it is moved from the inner surface to the outer surface. Am I correct?
Yes sir.
Right.
Yes, sir.
So when heat is moved from inner surface, that is combustion from the outer surface of the cylinder. If you touch it, you may feel it is a hot surface. Yes or right? Am I right?
Right, sir.
right?
Yes, sir.
So the heat is distributed by means of conduction. So it needs some cooling for it. It needs some cooling, right? To
Right.
to increase the cooling rate, the स्पिन लाइक स्ट्रक्चर, वो जो प्लेट दिखती है ना थोड़ी थोड़ी, आपको जो प्लेट्स बोल रहा हूँ मैं अभी, पर उसको इंजीनियरिंग लैंग्वेज, मैकेनिकल लैंग्वेज में उसको फिन्स बोलते हैं, FINS, फिन्स. सो दे कैन इंक्रीज द सिलेंडर, जो उसका आउटर एरिया होता है ना, उसका सरफेस एरिया इंक्रीज करती है. क्या करती है वो? सरफेस एरिया इंक्रीज करती है. सो इंक्रीजिंग द सरफेस एरिया इंक्रीज द हीट ट्रांसफर रेट एंड इट कैन बी नेचुरली कूल्ड. समझ में आ रहा है सबको?
हाँ सर.
सो व्हेन यू आर इन रनिंग कंडीशन, आपकी जब बाइक रनिंग कंडीशन में होती है, तो आपको कुछ ऐसे सामने से जो विंड आता है उसका फोर्स महसूस होता है. सही है? So
हाँ
the
सर.
engine also feels that force and the air is passing through the gap between the plates. जो दो प्लेट के बीच में जो गैप होता है उसके अंदर से वो एयर पास होती है. सो उसके कारण क्या होता है, जो भी हीट होती है, इट इज टेकन अवे विद द दैट एयर फ्लोइंग बिटवीन दैट टू plates and that feels, you can say, and the engine temperature maintained at a not room temperature but at minimum level, that the piston not welded inside the cylinder of the engine or cylinder block. तो उसके लिए वो रनिंग क्या रहता है. और जब भी आपका सिलेंडर और आपका यू कैन से दैट बाइक रनिंग कंडीशन में नहीं होता, तो जब वो रेस कंडीशन में होता है, तभी भी नेचुरल सर्कुलेशन जो एयर को दो फिन के और जो प्लेट्स होते हैं उसके अंदर से जो पास होती है, उसके कारण उसका कूलिंग इफेक्टिव हो जाता है और वो कूल जल्दी हो जाता है. उसको फैन की जरूरत नहीं होती. बट इट इज फ्रॉम डिफरेंट मोपेड्स, जो एक्टिवा, टीवीएस, जुपिटर एक्सेट्रा, वेस्पा जो होते हैं, उनका इंजन होता है वो सीट के नीचे होता है. Am I right? In between two wheels. For that case, they can use the external fan to cool that engine. It is rather what different things. हाँ, ये जो बाइक का इंजन और ये इंजन different है. For your information, they use some fans in Activa or Jupiter here because there is no natural circulation happen in the case. They can use they can run by the CVT arrangement, continuous variable transmission. So whatever the modes of the heat transfers are really important for the students, whether they with respect to the any of branch. So that is about the mechanical engineering. Second is the electrical engineering. Cooling of motors, transformers, current carrying wires and fans and regulators. अब आपने देखा होगा जहाँ पे भी कंट्रोल पैनल्स होंगे वहाँ पे एसी लगा हुआ रहता है. सही है?
क्या सर?
Whether the control panels are there, they can provide it with AC. कंट्रोल पैनल्स पता है आपको?
No.
नहीं सर.
Okay, so it is one of the room that where all controls are there. They can heat it due to continuous operating conditions. They contain different types of switches and relays. So they can need cooling arrangement. So where there is need according to AC or fans are to be installed. So आपने अगर विजिट किया है किसी पावर स्टेशन को, तो वहाँ पे बहुत सारा बड़ा ट्रांसफार्मर होता है, बहुत ह्यूज साइज का ट्रांसफार्मर होता है. पता है क्या?
हाँ सर.
राइट. तो उसके 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 आजू बाजू में आपने देखा होगा, वहां पे भी एक ऐसे प्लेट लाइक स्ट्रक्चर होता है जिनके बीच में गैप होता है. देखा है ट्रांसफार्मर में?
Yes sir.
Yes
तो
sir.
ट्रांसफार्मर में क्या होता है, फॉर द स्टूडेंट्स ऑफ इलेक्ट्रिकल इंजीनियरिंग, द ऑयल इज फ्लोड. ट्रांसफार्मर में जो ऑयल होता है वो ऑयल फ्लो होता है, और वो ऑयल जो होता है वो कंटिन्यूअस ऑपरेशन में रहता है. उसके कारण क्या हो जाता है, ऑयल हीट हो जाता है. तो ट्रांसफार्मर में आपने देखा होगा कि कुछ जगह पे फैंस लगाए हुए रहते हैं. For it is for cooling the oil inside the flowing inside the transformer. Just a minute, आपको समझ में नहीं आएगा. I am showing you one of the video picture of it.
काल एवढं होतं बा 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 बा
Please
तीन
unmute
गोष्ट होती.
yourself.
अंडे त्याच्यानंतर ते वरण भात त्याच्यानंतर हे काय काय
Vedant.
म्हणतात?
Student, are you able to see this window now?
Yes, sir, we are able to.
See this one. This one is called as a transformer, right? You see that this one also. ये दिख रहा है आपको ये ट्रांसफार्मर?
सर ये ट्रांसफार्मर कहाँ है?
This one is called as transformer. ये देखो आपको 1 2 3 4 5 6 7 8 टोटल 8 फैंस दिख रहे हैं यहाँ पे.
Yes, sir.
Yes, sir.
Say this one, such arrangement is to be done. ऐसे यहाँ पे फैंस लगाए जाते हैं ट्रांसफार्मर को कूल करने के लिए. ऐसे यहाँ पे देखो छोटा इमेज है. Are you getting my point? मुझे क्या बताना है आपको?
हाँ सर, ट्रांसफार्मर को कूलिंग करने के लिए वहां पे फैंस लगे होते हैं या तो उसमें एसी लगी होती है.
नहीं नहीं, जनरली द ट्रांसफार्मर जो बाहर रखे होते हैं वहां पे फैंस होता है. एसी नहीं इंस्टॉल कर सकते. एसी के लिए क्लोज रूम चाहिए होता है. फॉर योर इंफॉर्मेशन. ओके.
हाँ सर. हाँ.
So such arrangement is to be there and is required cooling. So it is to be means by means of conduction and convection. दोनों तरफ से इसका कूलिंग किया जाता है. So it's for information. So cooling of transformer ये समझ में आया सबको?
Yes, sir.
And then is for chemical engineering. Energy produced during the chemical reactions, heating or cooling of the chemicals for reaction requires some heat transfer. So they are not directly mixed with some of the liquids. So they can means they can be put in one of the utensils and they can be put in a, again it is both utensil can be put in a, you can say that water, cooled water. So they can be cooled because chemical not mixed with the water. And lastly the nuclear energy, that fission and fusion. हमने जो nuclear power plant में पढ़ा था, fission and fusion energy to of electricity, cooling of nuclear reactor is required. And to cooling the nuclear reactor, we require some element, that is controlling rods are used, moderators are used to control its chain reaction. After controlling this chain reaction, some water can be flowed from the outer body of the reactor to cool the total nuclear reactor. So that is the importance of the heat transfer. So heat transfer takes place in what? They can take away heat from the body, any type of body, right? आपका नेक्स्ट लेक्चर कितने बजे होता है बच्चों?
11:10.
ठीक है. Manish, you can stop here now. You drop your attendance in a chat box and leave the meeting. We can discuss this issue in a next lecture. In detail.
Thank you, sir.
Thank you all of you for listening this lecture carefully and replying me. So I can get that every student can get the knowledge of it, that what I am teaching to you.